So as you all know, atoms are not whole solid particles. They are divided into subatomic particles. There are many, more than 200 subatomic particles present in an atom. But we are concerned with only 3 fundamental subatomic particles, which you all are familiar with: protons, neutrons, and electrons. So this table is very important, as you must have seen past papers में इसके बहुत सारे questions आते हैं. It's such a simple table and you just have to fill in. So these are the 3 fundamental subatomic particles: electrons, protons, and neutrons. And you should know their symbol: electron small e, proton p, and neutron small n. Charges, you must remember their charges. Unit negative charge यानी -1 electron. Unit positive charge for proton 1 plus. Neutron 0 charge or neutral nil. Neutron word is from neutral, so it means no charge, 0. Location you should know about these particles: electrons revolve around the nucleus in shells or orbits. Protons reside in nucleus. Similarly, neutrons reside in nucleus. These are nucleon particles. Both of these are nucleon particles, you must remember. Now their masses. Relative mass of these particles are important. Electron's mass is negligible as compared to the mass of proton and neutron. The relative mass of an electron is 1 over 1836. You can also write 1 over 1840. Or 1 over 2000. All these 3 statements are correct. So any value you can learn. Proton mass 1. Neutron is approximately equal to proton, so it's also 1. So these are not 1 grams, as you all know. These are atomic mass units. Okay, so mass of an electron is negligible as compared to the mass of proton and neutron. That's why when we calculate the mass of an atom, we don't count electrons. We just count protons and neutrons for mass number. Okay. Here comes the first 3 elements, simplest elements, starting from hydrogen. So you should know how to draw their structures, how to find the number of protons, electrons, and neutrons in an atom using its proton number and its nucleon number. Remember, with the symbol of every element, 2 numbers are given. The smaller number is its atomic number or proton number, while the larger number is its mass number or nucleon number. Okay? Using these 2 numbers, we can easily calculate the number of protons, neutrons, and electrons in an atom. The number of protons are always equal to the number of electrons in an atom. That is why an atom is neutral. Sometimes they do ask this question, okay, why an atom is neutral? Because the number of positive protons are equal to the number of negative electrons. So the total charge on an atom is neutral, 0. Whenever an atom loses or gains electron, then these numbers are disturbed. They become unequal, and because of that, an atom may carry charge and change into an ion. So for hydrogen, the proton number is 1, so it has 1 proton. If it has 1 proton, it must have 1 electron, as shown in the diagram. And hydrogen is the only element which has no neutron. Now remember, sometimes MCQs they do give a question, okay, most of atoms have neutron number equal to proton or greater than proton. Is it true? It's not true, because hydrogen there is no neutron, so neutron number is less than proton. So it's not true for hydrogen. You can't say it for hydrogen. For all the elements you can't say it. For most of the atoms, the number of neutron is either equal to the number of proton or greater than number of proton. Okay? So for helium, you can see the symbol 2, 4, 2 numbers are given. So it has 2 protons. Neutron number is found by subtracting the 2 numbers. So 4 minus 2, it has 2 neutrons. And as it has 2 protons, so it must have 2 electrons, and both will reside in the first shell. Then we come to towards lithium. Lithium has a proton number of 3, so it has 3 protons. Neutrons 7 minus 3, 4. Electrons are 3, but the first shell can only hold 2 electrons. You know the capacity of the first shell is 2. So out of these 3 electrons, 2 electrons move to the first shell and the third electron moves to the second shell. So its configuration becomes 2, 1. Now comes isotopes. Isotopes are the atoms of the same element having same number of protons and electrons but different number of neutrons. So you must remember, whenever you are stating the definition of an isotope, you must say that they have the same number of protons and electrons. And when you are selecting isotopes from a list, please see that the isotopes should have, because these are atoms, these are not ions, so these should have equal number of protons and electrons. Only their neutron number should be different. This is a catch. It often comes that they do give isotopes mixed with ions. So you should not select ion for an isotope. Okay. So these are the 3 isotopes of hydrogen atom. Hydrogen 1, hydrogen 2 and hydrogen 3. You should know their names as well. Hydrogen 1 is known as protium. Hydrogen 2 is known as deuterium. And sometimes it's given the symbol D. Hydrogen 3 is known as tritium. And it's also given the symbol T. Okay. So from their mass number, you can see that all of these have the same proton number. Only their mass numbers are different. Nucleon number are different. So all of these have same number of proton. That's shown by their proton number, 1 each. And if they have 1 proton, so they all have 1 electron common to them. But their neutron numbers are different. And how do you calculate neutron number? By subtracting the 2 numbers. So 1 minus 1, 0. Protium has no neutron. Whereas deuterium has 1 neutron. 2 minus 1, 1. And the tritium has 2 neutrons. 3 minus 1, 2. It is the heaviest isotope of hydrogen. Deuterium and tritium both are quite rare. Tritium is the rarest. It's also radioactive. Deuterium is found in heavy water. You must protium oxide, not the hydrogen, proper protium oxide. The common water which we drink contains the first isotope of hydrogen, that is protium. But the heavy water contains deuterium oxide, which is used in nuclear reactions. Nuclear reactors may use them. Okay, now comes the properties of isotopes. You should be familiar with what things are common of protons and electrons. And as their electrons are same, so their chemical properties are also same. जिस तरह हाइड्रोजन प्रोटियम बिहेव करता है वैसे ही ड्यूट्रियम भी करेगा, वैसे ही ट्यूट्रियम भी करेगा. If protium makes water, deuterium will also make water. Tritium will also make water. What will be the difference? The difference will be only in the mass of the water. When you calculate the molecular mass of water, H2O की different होगी, D2O की different होगी, T2O की different होगी, according to their mass number. So that's the only difference. Otherwise, all 3 isotopes will make water with oxygen and water will be liquid. So chemical properties of isotopes do not change. Then comes the neutron number. Neutron number is different in isotopes, and as neutron number is counted in the mass of an atom, so the mass will be different for isotope. And when physical properties of an atom depends on its mass. So isotopes have different masses and hence different physical properties. उनकी physical properties different होती हैं. Their boiling point may vary, densities may vary, right? Okay, so example, hydrogen 2 has a slightly higher boiling point and density than hydrogen 1. Obviously heavier होगा, जैसे जैसे AR बढ़ेगी उसकी density भी बढ़ेगी, boiling point भी बढ़ेगा. Similarities में उन्होंने दिखाया कि क्लोरीन के दो आइसोटोप्स होते हैं, क्लोरीन 35 एंड क्लोरीन 37. बोथ हैव सेम केमिकल प्रॉपर्टीज क्योंकि उनमें नंबर ऑफ इलेक्ट्रॉन सेम है. So they behave similarly, they undergo same types of reaction. So remember, isotopes have same chemical properties but different physical properties. Right, then comes the uses of isotope. This is a table given here. You don't have to go in detail, just remember कि जो radioactive isotopes होते हैं, the isotopes which give out example in because these can be detected due to their radiations. For example, Technetium 99 detection of tumors में use होता है, Iodine 131 used for treatment of thyroid disorders, cancer radiotherapy में भी Cobalt 60 use होता है. So you should just know that radioactive isotopes are used, have many uses in medicines as well as कार्बन डेटिंग में कार्बन 14 हम यूज करते हैं टू फाइंड द एज ऑफ एन ऑब्जेक्ट. ठीक है, जियोलॉजी में ये यूज होता है. सो इन दिस स्लाइड वी आर गोइंग टू डिस्कस अबाउट द इलेक्ट्रॉन अरेंजमेंट ऑफ एन एटम. इलेक्ट्रॉनिक कॉन्फ़िगरेशन भी कहते हैं, वी कॉल इट इलेक्ट्रॉनिक अरेंजमेंट. Protons and neutrons are concentrated in the nucleus, but electrons are not concentrated in one place. They are moving around nucleus in different shells. There are different shells, energy levels around the nucleus. And how many electrons can be accommodated in an energy level is given by a formula, a simple formula. That is, number of electron is equal to 2n square, where n is the number of shell. So for the first shell or first orbit, n is 1. Then 2 into 1 square, first shell can hold only 2 electrons. For second shell, n is 2. So 2 times 2 square, that will be equal to 8. Second shell can hold up to 8 electrons. That's the maximum capacity of second shell. If you have more electron, they'll move to the third shell. The capacity of the third shell is, if you count it, 2 into 3 square, and that makes it 18, not 8. But as in our syllabus, we are going to cover only the first 20 elements. So we are fixing the number of electrons to 8 in the third shell, because if the third shell is the outermost shell, it cannot have more than 8 electrons. That's the octet rule. Maximum number of electrons in the outermost shell should be 8. So for that point of view, we only fill 8 electrons in the third shell and the rest go to the fourth shell. Fourth shell does have a capacity of 32 electrons, but that is beyond our syllabus.